Assalamu alaikum. Dear students, I'm back with another lecture that is symbols of atoms of the elements. My dear students, last time we discussed how big are atoms actually, and I said at that very time, I told you people rather that this atom is actually ultimate particle of matter. That means Dalton's atomic theory gave us the concept of atom as the smallest particle of the matter. That means the ultimate particle of an element is an atom. So this atom is actually the smallest particle of element which may or may not have independent existence, my dear students. We discussed this thing. So I told you people that no doubt, my dear students, these atoms are so insignificant in size. That means they are very meager in size, they are very meager mass, they are very small, tiny particles. But I told you people in the last video lecture, the moment they have meager mass, insignificant mass, then why we bother about them rather? The answer of that question is we can't ignore atoms at all because our entire world is made up of atoms. We may not be able to see them. I'm talking about atoms, my dear students. We may not be able to see them because they're extremely small, but atoms are there and are constantly affecting us whatever we do. So, and one more thing we discussed there, that modern technique, say modern technology has made it possible to take photographs of atoms. No doubt they have a meager mass. We can't see them by naked eyes. But modern technology has made it possible to take photographs of atoms. And those photographs are taken with the help of sophisticated instruments. And one of the instrument we discussed in the last video lecture is, my dear students, that is STM. STM. That is scanning tunneling microscope. And it was developed in 1981. Now the question arises, what's this scanning tunneling microscope? It's actually a microscope or instrument for imaging surfaces at the atomic level. That means we can see the atoms by making use of this scanning tunneling microscope. It was developed in 1981 by the two physicists named as Gert Benning, GERD, Gert Benning. This question has been asked so many times in the examinations. And Heinrich Rohrer. So somebody will pose you a question that what is this STM? So STM is actually scanning tunneling microscope, is an actually instrument for imaging surfaces at the atomic level. It was actually developed in 1981 and by these two physicians, I can say two physicists rather. One is Gerd Benning and Heinrich Rohrer in 1981, and in 1986 they got Nobel Prize for this discovery, my dear students. So these two scientists, Gerd Benning and Heinrich Rohrer, developed STM. By making use of this STM, we can see these insignificant, rather small as tiny particles called as atoms. And in 1986, they got Nobel Prize for the same invention, my dear students. So this was scanning tunneling microscope. Now, today we are going to discuss one more subtopic of this unit, that's atoms and molecules, that's symbols of atoms of the elements. Let's discuss symbols of atoms of the elements, my dear students. So, dear students, let's discuss symbols of atoms of different elements. Before discussing symbols of atoms of the elements, let me tell you people one important thing here. A question comes in our minds that why we represent elements by their respective symbols. For example, as far as periodic table is concerned, we have 118 elements. Just go through periodic table at your homes, my dear students. The moment you people will introspect, every single element you people will see is represented by its particular symbol. Now the question arises, rather a layman will pose your question, why there is a need to represent every single element by their respective symbols. Let me tell you people why we represent these elements by respective symbols. The only funda behind writing the symbols of elements is to make their study systematic and easy. So somebody will pose your question that why we represent elements by their respective symbols. The only funda behind writing symbols of elements is to make their study systematic and easy, and it becomes easy for we people to write or to remember those elements. That's why you people are seeing 118 elements represented by their respective symbols, and that's why this periodic table is used in schools and colleges as a teaching aid, because it becomes very easy for the students, rather for teachers as well, to memorize these 118 elements by, I can say, along with their symbols. So only funda behind writing symbols of elements is to make their study systematic and easy, and it becomes easy for we people to write and to remember. The names of some of the elements are very ancient. Let me tell you people that names of some elements are very ancient. They were, during ancient times, I mean to say, elements were generally named from the name of the place or where they were found for the first time. For example, before discussing in detail, let me tell you people that I told you people that during ancient times, elements were generally named from the name of the place where they were first found for the first time. For example, the name of the copper. As far as copper is concerned, the name of the copper is derived from Cyprus, where the element was once mined. So the name of the copper is derived. I'm talking about the ancient times, my dear students. Mark my words. I'm not talking about modern periodic table, modern symbols. I'm not talking about these symbols, modern symbols. I'm talking about ancient times. So ancient times means when there was not periodic table. So as far as this copper is concerned, this copper was actually derived from Cyprus. So some other elements were named after the specific color. For example, names were taken from the specific color. That means element was named after its specific color. For example, the word gold is derived from the word gold. Gold is one of the element. This gold is derived from the old English word meaning yellow. That's why you people are seeing the gold. As far as gold is concerned, you people will see this gold in yellow color. So that's all because the word gold is derived from the old English word meaning yellow. That's specific color. So some names describe a characteristic property. For example, chlorine is a yellow. Whenever I talk about this chlorine is one of the elements as far as periodic table is concerned. Chlorine is actually a yellow-green gas. Yellow-green gas. Mark my words, dear students. This chlorine is a yellow-green gas. And its name is derived from Greek word meaning yellow-green. Yellow-green. So, during ancient times, elements were named from the name of the place where they were found for the first times, or they were firstly mined, or some elements were named after specific color, and some I can say elements were named because they were describing a characteristic property. For example, I gave the example for chlorine. Chlorine is actually a yellow-green gas, and its name was derived from the Greek word meaning yellow-green. So these were some of the, actually this was a historic background as far as symbols of atoms of different elements were concerned. In the next video lecture, my dear students, we are going to discuss some of the Dalton symbols and alchemist symbols. These were actually the two chemists. Regarding the symbols of those alchemist symbols and the Dalton symbols, we are going to discuss those in the next video lecture. But one thing you must remember, that these symbols actually why we represent elements by respect symbols, because it makes our study systematic and easy. In next video lecture we are going to discuss some more I can say symbols as far as alchemist, one of the chemists, and the Dalton's symbols are concerned. Till then, stay safe, stay at your homes, keep practicing, my dear students. Allah bless you all. Thank you for watching this, my dear students.